good morning, everybody, or good day, depending on whichever time zone you're in. My name is Vasilis Strelka. I'm a senior principal training consultant working for OU, and we're about to start this presentation, which investigates what things have happened in Java since the, sort of latest evolution, once we pass version 8 and go into 9, 10, and, 12 versions of the language. Now, it's quite a lot actually happening here. First of all, we have a new modular system in Java, which is called Java Platform Module System, previously known as Project Jigsaw. So basically, we're looking at what the modules are, how they could be used, how to define dependencies between modules, expose the content of one module to others, produce and consume modular services, and then deploy modularized applications. This is a significantly different way of packaging and distributing the code. Another interesting feature is the use of a tool called JShell, which is kind of command line sort of scripting tool we could use with Java. And then there's another section in the presentation which talks about a variety of different language, API, and runtime enhancements, including the use of private interface methods, with resource improvements, local variable type inference, the introduction of the HTTP2 client, various API enhancements, Java virtual machine management, and performance enhancements. And also we'll talk about the adoption of new Java versions and kind of what we need to do and think with regards to moving to the new releases. First, let's start with where we've been before, which is non-modular Java. Before version 9, there were no modules in Java. The way to control access to classes were, you have the packages, so you could logically group classes to packages, that's fine, but there were no physical restrictions imposed on how they're used. Actually, right here in this example, you can see that you could use reflection API, dynamically introspect the code of another class, and basically ignore the fact that you're not supposed to see it, or, being able to observe its private variables or methods. And the fact that there is some kind of a physical restriction accessing the class, it wasn't the case. So the classes were packaged into just jar files, accessed via the class path, but no enforcement that all the related classes should be deployed together has ever been in place. You could easily forget to deploy a particular part of the application or deploy your own version of the class. At the point where the application is packaged and deployed, such verifications didn't occur. All right, so that seems to be a bit of a maintenance issue. The code kind of works. It's not really a physical problem as such, but it could be a maintenance issue when it goes into, long-term sort of production cycle where we start thinking about the evolution of the code. So the modules were introduced to address this. Module is a high-level code aggregation. The point of the module is to put all closely related packages together, classes, related resources, pictures, files, whatever you need, and describe them as one physical deployment unit. Now, the module names must be unique. And that's quite categorical, so that means you have to enforce the uniqueness in the naming convention. The suggestion is that you group a number of packages together, or you choose one package, which you consider kind of the, your root package for that module, the kind of the important one, if you like. Yeah, there might be other packages in the module, but you choose one, and you use that as the module name, following the same naming convention as you use for any other Java packages, which is typically reverse DNS name to ensure the uniqueness. Now, the module info class can then describe what other modules this module depends on. So what do you also need to bring into the deployment? The relationships between modules, what content does this module export to others, and you can be very restrictive there. You could basically say only certain bits of the module are to be visible outside of it. So permissions to open that content, essentially. You could give permissions to use as to. So apparently now you can impose a physical restriction on the code that does not allow you using reselection, which basically keeps private things, well, really private. You may offer services from modules and consume these services in other modules. And one more important thing, modules do not allow to split content of a package into two different modules, even if it is private. It doesn't matter. So basically what we're saying is that if you put some package content from classes into one module, then all the classes from the same package cannot possibly be placed in another module, which kind of keeps things together, in one consistent deployment unit. So that is your Java Platform Moduling System. It's based on these principles. Starting from JDK 9, all existing JDK APIs are actually patched as modules. They're described with relevant module info descriptors, which is either at the module root directory or in a subfolder which has the same name as the module. Why would you put the module info in a subfolder? Just in case if you decided you want to develop several modules together, physically deploy them in one archive, you can, yeah? And then, of course, the module info is a name of the file, so it will conflict with another module info. You cannot have two in the same folder. That's why you could put additional subfolder there. But that's up to you. Otherwise, you can just put module info in the root directory if you have just sort of one file per module, one archive per module. That's up to you. The module name must be unique and typically corresponds to the primary package that this module contains. Now, of course, it can contain other packages. You may decide to expose some of them to other modules, describe how they're exposed, what are the dependencies between them. Some packages may be completely hidden inside the module. The advantages of this approach is, first of all, we guarantee much more consistent deployment, and we can create applications with significantly smaller footprint, because we now can tell exactly which other things the application uses. We don't have to carry the entire Java development kit on board with our application. We can just, carry the bits we want rather than the whole thing. Because we know which bits we want, because there's explicit description of a dependency between the components. Also, when you run in the application, the dependencies are verified at a startup. So you cannot have an accidentally sort of running things without having necessary components. And classes in modularized applications are loaded differently. Instead of the variable class path, use a variable module path. A little bit later, I'll mention that for migration reasons, you can actually use both together at the same time, but that's kind of just intended to be something that you temporarily do whilst you're migrating from non-modular to modular deployments. But otherwise, you just use module path rather than class path. Just a few words on what are the modules that are already available within Java Development Kit. There will be Java SE modules, a group of modules that have a convention sort of naming around them called java.base, java.se, java.logging, etc. Just some examples. And then there are also implementation-specific modules that start from JDK. For example, JDK HTTP Server, JDK Console, etc. Yeah? And there might be, of course, other modules, including those that you create. If you want to find out what are the modules available within your Java SE environment, a simple command, java --list -modules will do the trick. It will tell you which modules you've got. Now, if you want to define a dependency between modules, this is what you do. As an example, a snippet of code from the module info Java file. In this example, we're saying that we require a certain module. My module called consum, whatever, requires to use Java logging or CACME, confu, whatever, so some other modules. a slight variation in the way in which you can require another module. Requires transitive directive makes dependent module available to other modules. So COM_SUM module requires transitive org ACME, which means whoever needs COM_SUM will implicitly require org ACME as well. So you kind of describe in the dependency that those who use this module will implicitly have. They wouldn't have to explicitly declare it. The static is a dependency which is enforced at compile time only. The regular dependency, the regular requires dependency, is verified upon the application startup. But if you say it's static, it will not be verified upon application startup. For example, if you want to link a kind of an optional framework to your application, which you may or may not decide to use based on specific deployment, that could be a static requires directive. One requires directive always exists, and that is requires Java base, which is kind of the core module without which you can't really do anything in Java. So there you go. Oh, and of course, required directives, as well as other directives here, could have a comma-separated list. So you could just say requires that module, comma, that module, etc., etc. Now, how do you expose content of one module to others? That's done with export directives. So some module says, oh, I'd like to make a particular package and members of it available to other modules, exports, and then the package name. You could qualify that you export package content to everyone or to specific other modules. Again, comma-separated list is possible. So in this particular example, we're saying module other could see package contents of package A. Well, it's a class L, it's a public class, it could see it. It could see contents of package B, demos B, some class N. What it can't see, for example, is class M, because although it's in a package that is exposed to external world, the class is not public. Ah, well, that restricts the use of it. So you won't be able to see it from other modules. Of course, and then another example here is this module 2 that cannot see the contents of package B because that hasn't been exposed to it, and nothing has been exposed to module SUM, so there you go. Particular packages, public members of which you want to make available for other modules. That's the idea. This is the actual example, what the modules could look like. Imagine you have a project where you develop a couple of modules. I doubt that in real world that's the way you structure the code. You can actually have separate projects per module, but that's up to you. You know, no requirement that you have to do it in a particular way. Because there are two modules in the same project, the subfolders are used to put module infos in the separate places. So there is one module that describes some kind of shop application. There's another module that describes data model, you know, access to the database classes. And the idea here is that you kind of have a front-end, back-end part, and the front-end requires the back-end. And think about it this way, that back-end could be tied into different front-ends. So that module, which contains the demos.pm, you know, product management thing, will be a reusable module by different front ends potentially. So there might be other modules you develop that require that backend. In addition to the exports directive, we also have opens directive. It's kind of similar to exports, and in a sense that you can open the contents of the package to everyone or to specific other modules, but here's the difference. The difference is that open directive allows introspection, and exports doesn't. And that's really a crucial difference when you think about using classes in injection frameworks. They use reflection API, they use introspection. So basically, if you compare it to an earlier page class M was not visible to external world. You have default access, and you're not supposed to see it. But when you open the package A, actually external world can see it. But that said, you can still have packages in your module that are completely closed to external world. that other modules are not supposed to see. Also notice that in open situation, when you open packages from a module, other modules don't really have to have requires directive as such, because the Reflection API works dynamically, so you may dynamically investigate what is the contents of other modules. And you can mix and match. You can do the export, you can do the opens, obviously in the same module as much as you like, depending on what exactly you want to achieve. There is also this interesting directive that opens an entire module. Just says, whatever packages I've got inside, make it available to all external modules for the use with Reflection capabilities. So you could do that. No private kind of packages in that module then. Now, another interesting trick is that you can describe a module that produces or consumes services. Here's an example. You describe an abstract class or an interface, probably an interface actually, but technically could be an abstract class, which has certain implementations. Yeah? So in this case, let's say demos AL is an interface and it's implemented by some classes. You then explain in a module that that is what the module provides as a service, provides that interface with particular implementations. Implementations may actually reside in different modules, if you like. You can link them together. So the actual physical class that contains the implementation may reside in another module. That's up to you. Anyway, and then your module that uses that service will use users directive to indicate which service it would like to consume. So it's another way of describing the dependency between modules. Again, I could show you an example of a service. So we evolve the same example you've seen a moment ago. We have a client application. That's one module. Then we have a backend part, which is this demos.data. And suppose it shows us some kind of data objects. They could be used by both the client and sort of a business logic module here. To reference that data, the intermediate module, which contains the business model, uses transitive dependency, so we don't have to include demos data as an explicit dependency into the client. And then the idea is that this intermediary business logic module can provide different implementations of the logic as a database, a file system, whatever, storage you might wish to implement, but the client can access that through an injection, essentially, of a module dependency, which says, I'm using that product manager, the interface, yeah? So you can then decide upon which particular implementation you'd like to provide. There you go. Also, you may create a multi-release jar file. For example, to match different versions of Java runtime, providing version-specific code for every version. It's not that you really have to do it, but if there is something in your application that would like to be sort of, more particular about a version of Java that you use, you can actually package the code that way. Now, in a multi-release jar, which is certainly an important new feature, you could use that in conjunction with modules. You see, the multi-release jar could be created without actually using modules, just by creating subfolders that match different versions of Java and use it in a class path. You could do that. But if it's modular, then there are two ways you could do that. First, you can put a default version into the root folder, which could be a module, or you can put non-modular version of the application into the root folder, and then you could have modular versions in specific subfolders, essentially. So that's up to you. How would you like to treat it? Because you may create a module that could work with, say, for example, versions of Java before multi-release has been, or modules became available, and then you can have the same archive used for the later versions as well. That's entirely up to you. At least you have that flexibility of choice now. How to physically do it? Slight differences in the way you compile and package the code. Notice that the difference is essentially the use of module path instead of class path. Yeah, so you point to other modules when you compile Javac, module path. In previous versions, that was class path. Package into jar file, pretty much the same as you've been doing it before. You path to compiled code, create another jar, file name. Optionally, if the module contains main class, where is that package and main class? That's up to you. You can verify the package module by pointing to the module using the module path and doing this -- describe module and which module you would like to describe. Yeah, so that tells you the kind of print out back the structure of the module, what are the dependencies, etc. If you want to execute a modularized application, you can use the module path, which is how you're supposed to do it, and point to the module name. If you have described the main class in that module, you don't have to put package name, class name, just the module name. If you didn't describe the main class, oh well, then module name and then the package and class name. You could still use the class path. Absolutely, you can. You know, the modular jar will physically run on a class path. But this is the thing. If you access a modular jar through the class path, that means you're kind of reverting to the pre-module state of Java, in which case all these jars are kind of assigned to one unnamed module. Anything that's in the class path is one unnamed module. That allows you to take an existing legacy jars that are not modules and use them in a modularized world as if they are modules. Because you can use the class path and -p, the module path, simultaneously. Here's the thing though. What would be the other option for you? You can take the legacy jar and put it into a module path rather than class path. How about that? In which case, they do become modules, the legacy jars. The modules that kind of really open to everything and require everything because there are no dependencies described for them, so they kind of depend upon the entire world, yeah? Unavoidably so, but there's a temporary measure for migration that could be the case. However, if you just place the non-modular jar into the module path and you created an automatic module, what would be the module name? Well, that's a problem, because there will be a jar file name, which is definitely not guaranteed to be unique. That's seriously a problem, because module names must be unique. So what you could do in a jar file, you can just add an automatic module name to manifest MF and control the name. And that's how you can just grab an existing jar, which is non-modular one, and use it in a module path until such time when you figure out what the module info for it should be and repackage. Yeah? So that's kind of your migratory options. Yeah? Okay. Another new feature is an ability to use a utility called JLink, which allows you to create an image of your actual runtime. When you use a JLink, you can add different modules together. So you can point to your modules. Now, it says here in the PowerPoint, module path, path to compiled modules, and Java Home JMods folder. This Java Home JMods folder, that part should only be used in JLink utility when you're creating an image for another platform that's not your current. If you don't put Java Home JMods in a module path in there, you create runtime image, all right, implying that it will be executed on whichever platform you created it. If you want to create runtime image for a different platform, not the current one on which you're doing it, download the JDK, unpack it for that other platform, unpack it to a local folder, and point here to its JMods folder. And that will create runtime image for another platform. So what you're creating here is platform-specific deployment. But the trick is, you can add modules to it, you can bind services with it, you can define a shortcut like a, command with which you can launch it, describe an output folder for runtime image, and that packs the actual runtime into it. But the thing is, it doesn't pack the entire Java development kit. It packs into that module only the bits that your code actually needs based on the dependency. So the footprint of the runtime image is much smaller, and it doesn't require the target machine to actually have a JDK installed. You can simply download that, and that would be your standalone program with no further external dependency. Fancy that. You can check which modules are included into it, etc. The way of executing runtime image could be Java -m module name. Presumably, if the module name already defines where the main class is, then it just runs it. Or command name if in a JLink you provided an alias for launching the module, launching a particular command. But they say the good news is that you don't have to have a Java runtime installed, because it will be carried within the module itself, within that image itself. Various options to optimize the runtime image. You could do the compression, you could use or don't use headers, sweep debug information, optimize it for a particular VM, lots of different options here in JLink. All right, so that's formation of the image. And this concludes the part of the presentation that covered Java modules. So massive new feature, migration is pretty straightforward. Either add jars to the class path user together with module path, get them all in one main module, or put previous jars into the module path, get your automatic modules, describe how modules are linked, describe if you want to use introspection or not, opens or exports, and maybe you want to use services, and off you go. Build up your image, and that's your distribution. Next, very simple, neat tool you could use is JShell. Allows you to type code, evaluate, and echo the response back instantaneously. Really useful stuff if you want to play around with Java, try things out in kind of a script sort of style fashion. These are the commands for the JShell, just, as a reference. It's pretty simple. The whole point is you don't need to learn it. You just use it. You type the commands and, it's kind of trying things, playing around, etc. Since SE11, you can actually use JShell to execute scripts. And, there's one more thing. Since SE11, instead of compiling the Java class properly, you can just say Java and then the path to the .java file rather than .class file. Presumably that contains method main, so it compiles and executes it for you instantaneously. I don't know. It's kind of similar ability to what JShell does, where you just type the code and it's instantaneously executed. Again, that's probably for experimenting with code reasons. That would be the rationale behind it. Java interfaces. Oh, wow, quite a new set of features here. Now, previously in sort of classic Java, we knew that interfaces were there to provide us with abstract method definitions. But now, since Java SE8 onwards, we have quite a few new abilities. In SE8, default and private methods were introduced to interfaces, and SE9, in SE8, default and static methods were introduced to interfaces, and SE9, private methods were introduced as well. The thing is, having a concrete code in interface shouldn't really bother you so long as you're not causing a conflict when implementing that interface. Obviously, private methods cannot possibly be viewed outside of the given, interface boundaries, so they cannot possibly cause the conflict for whichever child that implements that interface. So with static methods, because they can always be referred to using the specific type, so they don't cause a conflict, default methods can potentially cause a conflict. If a particular class implements two different interfaces, and they both happen to have a certain default method with exact same signature, oh well, then you have to override that method. But unless that happens, you don't really have to. So you do your usual thing, override abstract methods, but the interface now can carry a reasonable amount of code with it, which kind of makes me draw an important conclusion. There is no much reason now for having abstract classes, because you can do pretty much the same stuff with interfaces now. Anyway, just a thought, yeah? And still might be a use case for an abstract class, but it's definitely sort of laying heavily on interfaces now rather than on other options to provide generic behaviors and generic definitions of behaviors. Here's an example that illustrates what happens with an interface implementation. Imagine you've got an interface X and Y. Interface X describes default method, so is the Y, and hey, they actually conflict. Yeah, see, the method B causes the conflict. Methods C and D do not cause conflicts because they could be referred to using either specific types or they are not visible outside of a given interface anyway. Now, we have this class Z, and it happens to extend the class W. Oh gosh, the class W coincidentally has a method E, which is exactly the same as an interface Y. That's why class Z doesn't have to override it, because it has, through inheritance, an implementation of a method, concrete implementation of a method that interface Y defines. So that's fine. However, class Z has to implement method B because there's a conflict between them in the X and the Y interfaces. And of course, they have to override the method A because that's the abstract method in the interface X, and there's no concrete implementation in the class Z for that method unless you override it. So with default methods, you may have to resolve the conflict. Okay, now, another small improvement in your code is try with resources. The try with resources has been available before in Java 7 and 8, but the new thing about it in SE9 is that you can actually declare and initialize a variable that you would like to use in a try with resources before the try block, and yet it will be correctly closed in the finally. So that is really handy, because previously you actually had to do the whole thing inside the try block parameters, which was, well, just less convenient, I guess. Now it's a small improvement, but handy. Next significant change that occurs in your code is a concept of local type inference, local type variable inference. Basically, if you describe a local variable, you can guess what it is that the variable type ought to be from how you initialize it. In which case, you don't have to put the actual type on a variable definition. Instead, you use this strange thing called var, which bizarrely enough is not a keyword. I know, yeah? Which basically means you can have a var called var, which is extremely bad idea, but syntactically correct. So yeah, it's kind of an indicator of the local variable inferred type. That's what var is, rather than it is an actual keyword as such. Anyway, well, what you're doing is that you're allowing Java to guess what the type is, yeah? For a local variable. It could be used for local variable, for indexes enhanced for loops, yeah, or variables declared in traditional for loops, maybe. But of course, bear in mind, overusing this feature could impact the code readability. Also, I need to point out one more thing. There is a good use case for local variable type inference when using lambda expressions. Suppose you type in a lambda. In lambda expressions, the type of parameters in the lambda can be inferred from the context. But if you just put the parameter name without putting its type, then you can't, in Lambdas, use any annotations or additional keywords, like you cannot describe the variable as final, or I don't know, you cannot use not null annotation, something like that. But if you put the word var, then you can. Okay, so that might be really useful. Unfortunately, that is only from Java SE 11 onwards. That feature was not immediately available with local variable type inference as it appeared in SE 10. The use of these inferred var objects is only allowed from SE 11 onwards if it's in a lambda. Yeah, but it could be quite useful. Now, even newer feature available in Java SE 12 is a switch expression. Now, there are kind of several things happening here. First of all, did you notice that cases are now, in this SE 12 onwards style, could have a comma, so you can list several cases. Okay, well, and then you could describe a sort of lambda token after the case name and just describe what the case returns. I mean, you could have a normal block. Of course you can. Normal block of code. You could have whatever logic, but you may use essentially what is a return value from the case. Technically speaking, it's not return keyword. It's break instead of return. But you can break and return a value, which is, well, interesting. Yeah. Okay. You don't really have to put the break and return a value. You can just type what you want to return, an expression, whatever. Yeah. But if you write in a block of code, then you need to add a break explicitly. Okay. So that's an interesting way of treating a switch. Yeah. It completely semantically changes what the switch does, of course. So still. Next, HTTP/2 client. New protocol, HTTP2. The actual introduction of HTTP2 client has been done in Java 9, but it has been an incubator module, so kind of gradually introducing that. It was refactored in 11 as JavaNet HTTP package, and then the WebSocket support was also added to that. The HTTP2 allows the bidirectional connection stream to be opened between the client and a server, capable of transferring both text and binary data, suppressing duplicate headers, enabling kind of server push. So that's an interesting thing to explore. Modern browsers started enabling support of HTTP2. And you could create both server-side components in modern Java EE versions, which support HTTP2, and the client side, as you can see, as well. So that's evolving now. Other significant API enhancements. Oh, quite a lot of them, really. There are things happening with collections, like, for example, producing and copying a collection, which is an immutable collection of values, matching and comparing content in arrays, various new methods there, processing streams with until or from specific point logic, and also creating asynchronous reactive stream handlings. These are the new features. New features in collectors, like flat mapping and filtering capabilities. Some new features in the optional class that enable to produce streams now, or execute consumer or runnable objects based on whatever the value is present inside the optional or not. Some features in the objects class, verifying the null or index boundaries, for example. Or enhancements in a scanner, like scanner can return a stream now, which is again quite useful. Enhancements in a process class that improves the way you handle external processes. Also enhancements in Java I/O and NIO, but they're just minor convenience operations. They're kind of not major new features, just handy stuff, slight automations. And some convenience operations added to the stream class, but again, not radical new features, just convenience methods. New classes include the introduction of process handler, which controls native processes, that is used together with the process class mentioned earlier. Also, together with the same process class, you use stack walker, that allows you to traverse the invocation stack and go forward and backward in a chain of invocation methods. And it's a thread-safe way of handling stack frames. And finally, the cleaner, which allows you to manually manage memory with phantom references and associate them with corresponding cleaning actions. So quite a few enhancements in that area. Some enhancements in locale support. Gradually introduced, starting in 9, where calendar and number modifiers were introduced to locale, proceeding to SE10 with currency, first day of the week, region, and time zone overrides. These are the classes that were affected by the change. They include, obviously, text formatting, the date API, calendars, so they could now take advantage of the new language support tags. Memory management. Significant changes in there. Although most of these changes are completely transparent to developers, unless you're writing your own garbage collector, I guess, Well, otherwise, if you're just using the runtime as an application developer, then you don't really normally directly exposed to that, but these are significant changes because they affect the performance of the Java virtual machine, improving the memory footprint. For example, sharing class definitions between instances of Java virtual machine. Enabling class sharing means that we could use the class sharing from Bootstrap and other class loaders, so it's useful, reducing memory consumption. The parallel full garbage collector called G1 has been introduced in SE9 and gradually made its way to becoming kind of default mainstream collector that you're supposed to use now. It can produce the garbage collection concurrently, which is useful. Also, in 12, as an interesting ability, that you can actually abort the garbage collection if it takes too long, and as a much quicker return of Java heap memory to the operation system if the OS is idle, so it allows you not to block too much memory when a garbage collector releases that, it can quickly be recycled by other OS processes. If you're developing your own garbage collectors, the API has been restructured, so you have one garbage collector interface you can implement. It's much easier to work with across different types of Java virtual machines. That's mostly for the benefit of those people who actually develop, system things for JVMs rather than just application developers. Also, heap allocation on alternative memory devices has been enabled. For example, ability to allocate heap memory and video memory rather than just main OS memory. Well, maybe, Other management and performance enhancements. These are available from SE10 onwards. Experimental just-in-time compiler has been added, which could improve the performance of your code. Thread local handshake. That's an interesting feature. It's kind of a cheap callback on threads without performing a VM safe point to stop an individual thread. Just that thread and not all threads, or, so instead of all or none, you could perform the synchronization with just a particular thread with that safe point. It's initially implemented in X60 Sparks and should gradually make its way to all other runtimes. By default, it's actually switched, but, you can turn it on and off, Slight change in packaging of the SSL certificates. Previously, they were only packed, the root certificates were only packed with Oracle JDK builds, but now they're available as open source build as well. The consolidation of Java Development Kit repositories happened into one streamlined development. And then the native header generation tool has been removed because its functionality has been incorporated into the JAVAC utility as of Java 8 onwards. Another interesting runtime-related set of features was introduced in SE10, and it makes Java Virtual Machine Docker aware. Problem in early versions was that when the JVM was executed within the Docker, it could have ignored the memory and CPU limitations you posed on the Docker and just use whatever, hardware you have. Now you can actually force the JVM to go and look at what the Docker tells it rather than at the physical hardware. So you may give access to particular CPUs, restrict CPU cycles, memory, impose memory limitations. Yeah, there you go. What Oracle does about Java? You notice that we are now in a situation where the new releases are coming out much more frequently, every 6 months. It doesn't mean that every new release has an equal amount of new features. No, not really. Yeah, some of them are significant changes, like, for example, version 9, which introduced modules. That was a massive change, yeah. And then, for example, 12, which is not really that different. Yeah, there are some new features you've noticed, but overall it's quite similar to 11, well, except the bits that we mentioned. Anyway, so some of the changes are more significant than others. But what is happening is that we cannot possibly maintain the old support model for all versions of Java. So we have kind of, in Oracle, made a decision to make certain Java versions short-term supported and certain versions extended support, long-term supported. For example, 11 is going to be long-term supported, whilst 9 and 10, not really. Yeah. So is 12, and then as we release new versions, we make a decision as to which next one will be long-term supported. There you go. So you could look at that table and decide which versions you could use as an experiment and which versions you really want to use as your basis of production. Yeah. Okay. Now, in Java EE world, there's also certain evolutionary things that happened. In EE7, there was a significant set of changes in EE7. New batch API, new concurrency API, JSON pre-processing, support for socket, completely rewritten frameworks such as GMS and Enterprise Java Beans significantly improved. Servlet supporting non-blocking I/O, HTTP protocol upgrades, much improved Java server faces. I wouldn't say the Java EE 8 is that significantly different, but there are some improvements there. Reactive client style for JAX-RS, more sort of annotation-driven security, API, rewritten JSON binding API, although the core of it is doing pretty much the same thing. Some of the support for the Bootstrap, CDI, context dependency injections, and HTTP2 support for servers, including the ability of server push. But I would definitely say that EE7 is a game changer. It doesn't resemble EE6. It's by a mile easier to code with, and actually works faster as well. And what's important, I would probably say that, it's like when in EE5 or whatever, early versions, 6, the early Java EEs, you were looking at the Java EE, and then you were saying, we're kind of lacking features here. Shall we use Spring? Yeah, that was justified. When you're looking at EE7, Spring is completely unjustified now. There's absolutely no reason why would you want to do that. There's the entire wish list of what developers wanted to have in Java EE, which wasn't there, is now there, and provided by the core platform without any add-ons. So that's easy to deploy and work with. Certification has changed. Oh yes, that's another big thing. Yeah, instead of SE8 Programmer 1, Programmer 2 exams, we now have one certification, which is actually two-part exam. So it's still 2 exams, but you don't have associate and professional certification badges. You just get one certification, which is Certified Professional. So that's the OCP for Java. 2 exams, but 1 certification. And then another streamlining occurred in the Java EE world. All of these exams that were EE6 exams, separate exams which were, Enterprise Java Beans Developer, Java Server Faces, blah, blah, blah. Yeah, gone completely. As of 31st of March 2019, forget them. There's 1 exam for the Java 7 certification developer and also OCP certification. Brand new course as well, brand new curriculum. It's just basically 1 course curriculum at the moment for Java 7. It's pretty straightforward. One of the reasons why we were able to drop all the separate exams and separate courses and just replace them with 1 is because that is how much more simple it is to work with EE7. There's simply less plumbing code you need to write. The runtime automates things for you significantly. So there is no need to, waste your time on doing the code that the system does for you now. And you can focus on the business logic instead. And hence the exam and the courseware, significantly simplified. It's easier to get through it, to get a certified status, and just understand the technology and utilize it on a day-to-day basis. So obviously we provide an equivalent training courses, as you could guess, for Java SE and Java E to prepare you to the certification exams, which is rather important. Whew, goodness me, that was a lot of information. A good chunk of this presentation was dedicated to the Java platform module system. Then we looked at JShell. Then we looked at other language and API enhancements and the process of adopting new Java versions, understanding which releases are long-term support versions, understanding the certification paths, and what do you need to do to migrate your legacy code to this new environment and, new platforms, especially when it comes to modules. Well, that would be it for the core part of the presentation. So thank you very much for your attention. And I'd like you to, if you have any questions, please go ahead and ask questions. You could use the chat for that. And so I can see the chat, yeah? Okay, so, right. I've been certified in Java E5. Would you recommend certifying E6? Does it work? It's radically different. The environment changed so significantly. A lot of code and the ways in which you're writing the code in early versions has changed. You definitely need to learn Java E7. Obviously, E5 coding techniques still work, but you're creating code that is less than optimal. Yeah, so definitely worth looking at EE7. You can do we have to pay for running Java 11? If you're using the open source, you don't. So it's just for things like Oracle, JDK. So basically it's support. Yeah, but open source, no, you don't. Just a second. Can I send messages to everybody? Yes, I can. I'm typing my email just in case if you have questions after the thing. Yeah, it will be in a chat. There you go. Well, if you want to send me an email later. Sharing the presentation, the guys from the OU who are organizing the event will probably do that. I don't know how it's done, but the organizers of the event do. They will address the question of sharing that presentation. I'm sure it will be available as recording as well. JShell understanding other JVM languages. You can understand Lambda expressions. So yeah, I mean, you could wrap things up in expressions and interpret that in JShell. But yeah, so if it's a Lambda expression, you can just put it in JShell directly. Yeah. It's a good question. How long the version 8 exams available for? I haven't heard of retirement date yet. so at least for a year. Isn't Java release cadence too fast? Most people still on Java 8. Do you know, this is okay. There's nothing wrong in staying in the old version. If that is your production environment, so be it. The release cadence is what it is. It's the decision that wasn't actually made by Oracle. This is now kind of open source group that controls it, which Oracle's a part of, but it's not our, sole decision. I don't really care how fast it is, even if they release it every day, I'll just ignore it. It doesn't matter. What it does allow me to do is understand what's coming in new versions. I understand which new versions will be long-term supported, and then I can plan my time and switch to the new. When we're going to release the book on Java 11 certification, I'm working on it. Other people, I'm sure, working on it too. So, good question. But no, I cannot give you the date. I don't have a clue yet. We finished writing the OCP 11 exam in late December, and then there were, phases of testing. So the exam just became available. It's obviously a little early for us to give anybody solid advices on that, because it's in early days. We need to gain our own experience with how people pass in these exams, and just see, where the maybe difficulties are and focus on these. So, but we're getting there. Classroom training for enhanced Java Beans and GMS is included into enhanced GMS in Java 10. In Java 10, do you mean, enhanced GMS in Java 10. If we're talking about Java SE, then GMS is not really related to that as such, is it? It's more like a Java EE, isn't it? And then, of course, we're looking at the Java EE 7 and 8, where there's no yet Java EE 10, so I'm not quite sure if the question addresses the version correctly. Yeah. So if you're asking, is the new JMS 2 API covered in our training? Absolutely. That's the primary focus of Java EE 7 course, to cover, one of the primary focuses of that, cover GMS version 2 API. All right. Well, no further questions, I guess. So, thank you very much, everybody, for attending. Have fun with Java, Java EE, get certified. These are important things. And, just in case you have my email in the chat. So there you go.